Stop. Did you know AI is facing a hidden danger that could destroy everything it knows? We're talking about model collapse. It's what happens when AI starts learning from itself. New research reveals a vicious cycle. AI-generated content is everywhere, being fed right back into the systems. The line between original human knowledge and AI-synthesized info is blurring into a digital echo chamber. Think more data equals better learning? Think again. Quality can actually plummet as AI feeds on its own distorted outputs. The two-island model shows how social segregation and speed make these systems incredibly fragile. Is faster always better? For AI, the answer is a shocking no. Speed actually destroys robustness. We're going deep into the research of Acemoglu and his team to uncover the truth about the future of knowledge. Let's get started.
Hey, so today we're jumping into some really fascinating new research that uncovers a kind of hidden danger in the way AI actually learns. Now, we all know AI is trained on stuff humans create, right? But what happens when it starts learning from its own content? Well, a brand new feedback loop is popping up, and it could totally change what our AI systems know and, more importantly, what they get wrong.
Okay, let's just get right to the heart of it with the one question this whole research paper is trying to answer. What happens when AI starts learning from itself? You can almost picture it like a digital snake eating its own tail. It creates this kind of AI echo chamber that researchers have a name for. They're calling it model collapse. And trust me, it has some massive implications for the future of knowledge itself.
So the problem really kicks off with what the paper calls the AI feedback loop. I mean, think about it. AI-generated content is everywhere online now. So it's getting scraped up and fed right back into the system as training data for the next generation of AI models.
So, and this is the crucial part, you get this recursive loop where an AI is basically learning from beliefs that it helped create. The line between real, original human info and AI-synthesized knowledge gets super blurry. And here's the really shocking part. The research shows that even if you have tons and tons of data, the quality of the AI's learning can actually get worse as it keeps feeding on its own, possibly distorted outputs.
To really wrap their heads around this, the researchers didn't just stick to theory. They actually built a digital lab to simulate this exact problem. They called it their two-island model, and it's honestly a pretty brilliant way to see all these forces in action.
Now, before we check out the model, we gotta get this one key concept down: homophily. It's a simple but really powerful idea from sociology. Basically, it's just birds of a feather flock together, you know? We all tend to hang out with and trust people who are already kinda like us. And this creates these natural information bubbles or echo chambers in our society.
So the researchers took that idea and built their simulation around it. They created this little digital world with two groups that are socially cut off from each other, a bigger majority island and a smaller minority island. And just like in real life, talking within an island is way more common than talking between the islands.
And yeah, this diagram just lays it all out perfectly. You can see the two islands, right? The blue majority and the red minority. And then you have this one global aggregator AI just kind of hovering over both of them. It's taking in info from both groups, mixing it all together, and then feeding this single, unified signal back down to everybody. The big question is, what does that signal actually represent?
This brings us to the first huge finding from the study, and it's all about speed. You know, we usually think faster is better with tech, but this research shows there's a really surprising and frankly dangerous trade-off.
It really forces us to stop and ask, when we're talking about an AI that learns from our society, is faster really always better? Well, the answer, as it turns out, is a huge no.
Okay, so what's so cool about this slide is how clearly it lays out that trade-off. The paper found that a slow updating AI, one that takes its time and refreshes its knowledge gradually, actually improves learning for everyone. It has time to kind of smooth out the weird biases and distortions from the two islands. But a fast updating AI, it becomes fragile. It just closely copies the current distorted beliefs of the population, makes them even louder, and feeds them right back into the system. It's a vicious cycle.
And this quote from the paper just nails it perfectly. The system ingests its own outputs. This feedback destroys robustness. When the AI updates too fast, it just loses its ability to reliably learn and get better, because all it's doing is echoing the echo chamber.
All right, so if speed is a major problem, what about bias? Let's take a look at how this crazy feedback loop messes with the imbalances that are already baked into the training data.
Now you might be thinking, well, can't we just fix this by reweighting the data? But it's not nearly that simple. If the AI just listens more to the majority island, it makes everything worse. The data imbalance and the social segregation just feed on each other. But here's the really wild part. Even if you try to fix it by telling the AI to listen more to the minority island, it only works sometimes. It might help a bit when segregation is moderate, But if the islands are too separate or too connected, the whole thing can backfire.
And this, right here, is such a critical insight. Fixing AI bias is not some simple technical tweak you can make. The actual social structure of the data, how separated those islands are, completely changes whether a good intention fix is actually going to work or just blow up in our faces.
So if a single, giant global AI is this fragile, what's the alternative? Well, the researchers propose a completely different architecture, a much more local approach. Okay, let's look at these two models side by side. Over on the left, you've got that global aggregator we've been talking about, just lumping everything into one big system. But then look at the right, that's the local aggregator's idea. Imagine one is an expert on topic A, and it's trained mostly on the island that knows the most about topic A. Then another one is an expert on topic B, trained on the other island. See? They keep the feedback channels totally separate and specialized.
This table really breaks down the key differences. The global AIs pool everything together, creating one huge system-wide feedback loop where a mistake can spread everywhere. That's what makes it so fragile. But the local AIs, they use smaller, topic-specific sets of data. This basically compartmentalizes the feedback loops. So an error on one topic doesn't poison the well for another, making the entire system way more robust.
And the results are pretty stark. The research proves that these local aggregators just flat out improve learning. And they work because they anchor the training to the most informed sources on any given topic, which preserves all this valuable informational diversity. In fact, and this is a huge claim, the paper shows that if you replace a set of specialized local AIs with one giant global AI, you will always make learning worse on at least one of those topics. Always.
So this all builds to the final takeaway. And this isn't just some academic thought experiment. It really points to a fundamental choice that we have to make as the architects of these AI systems.
And here it is, the moral of the story. The most important design choice we're facing isn't just about making our AI models bigger or faster. It's about the structure of how they learn. How an AI learns, whether it's from one giant global pool or from many specialized local sources, is just as important, if not more important, than how much or how fast it learns.
Which leaves us with this final, really provocative question. As we're building the future of knowledge, should we be racing to create one giant, all-knowing AI? Or is the real path to robust, reliable intelligence actually paved with a whole network of many smaller, specialized AIs? This research suggests the answer might be the exact opposite of what big tech has been telling us.